Hello, meteorologist Rob Carmark with an El Nino update. As we all know, it's been in the news the last couple days. It is a big deal. It's a global phenomenon that has impacts worldwide, but I want to bring it a little bit closer to home for Northern California and what you can expect, and also some of the pitfalls that you might fall into, because it is a tricky thing to understand and it's not always set in stone. If El Nino is happening, X, Y, and Z will happen next. That's not always the case, as we'll get into. So at this point, we do believe that it's coming. It has potential to be strong, and there's going to be some impacts that more or less things that you can depend on, and also some things that are in the works that may be beneficial, and there may be a downside as well. So it's just a refresher of what's going on with El Nino. This is the sea surface temperature anomaly. That's a lot of words just to say, is the seawater at the surface warmer or colder than normal? As you would expect, if it's in these yellows and reds, warmer than normal. Blue is cooler than normal, and not by that much. It's a very delicate process. When you look at this one square here, this is what they call the Nino 3.4 region. And it's a mix of warmer water and also some cooler water. We're just coming out of a La Nina, which is where this is mostly blue, cooler than normal. So we're just now nudging out of that because there's a mix. That's where we are at the moment, and that's where it should turn redder and warmer than normal in the months ahead, and then El Nino effects start to happen. But this is the early sign here, this big pocket of red. I do need to mention during the course of this, there's lots of other things going on, which is what makes this very tricky. This is where we understand the El Nino region begins, the warmer water off South America, which starts actually on the other side of the ocean, but at any rate, it'll start to filter in, and then it will start affecting weather patterns in the near future. But we still have a lot of things going on. Near Baja and mainland Mexico, it's way warmer than normal. So that's one extra thing that you have to factor in. Sometimes we know what will happen, how it will modify. Some things are unknown, especially when you have combinations of things. A big blob of warm water in the central to western Pacific, that's a big deal too. And that could change how El Nino may affect our future weather patterns. When you go underneath the surface, this is a view that not a lot of people are paying attention to. So you have to think in 3 dimensions. This would be out toward Indonesia and out toward Australia. This would be where South America is. If you remember, that's where all the red was, the warmer water than normal. You can see it's a degree or 2 above normal. That's really ranking up there. But underneath the surface is something called a Kelvin wave. That's when it actually migrates from west to east underneath the surface of the water. These are actually buoys that have temperature gauges, so we can get a good understanding of what the temperature is and how it's changing over time, so you can get movement out of this. Underneath the surface is a big bubble of really warm water. As it migrates over, we expect it to make it all the way over to South America. It hits the surface, and then the trade winds will blow it over into that 3.4 region, which is right around here if you think back to that other map. So that's why the computer models are really latching onto the trend here, going from where we are in a neutral territory nicknamed La Nada between El Nino and La Nina, and we're all trending up here. The old models like this scenario, the new ones like it, and once you start to get to around 2 degrees centigrade above normal, you start to slip into the category that all of a sudden dominates the headlines. There's almost like this secret competition to try and outdo each other with the how to describe it. I've even heard with the last one, the Godzilla El Nino. Let's just stick to terms that are easy to understand. Weak up to super. This is roughly what we're looking at. A very strong area of warmer water in the 3.4 region that I talked about 2 degrees or warmer. We've only seen this in recent history a handful of times. 82, 83, monster situation for California, rain and flooding. Then it happened again, 97, 98. That was also a huge water year and a huge rainy and flooding year for all of California, by the way. And then 2015, 2016, you may remember this one. That one, we talked about it a lot, and the exact opposite happened. In Southern California, we did not get a lot of rain, which is what we were expecting, and what, frankly, we were hoping for. We were in the middle of a very serious drought. And then Northern California did okay. So again, it's a often not always situation. Your standard way that the trade winds blow is this normal scenario, but when they reverse and you get those Kelvin waves, that's when you start to see El Nino conditions develop. And over time, we've got a lot of data on this rough scenario when you include the weak and some of the middle categories of El Nino. It roughly looks like this. There's a lot of examples where it's not looking like this. Like I mentioned, that super El Nino 2015, 2016, it was not this way. But overall, we tend to see wetter conditions for Southern California, the desert Southwest. We also see, by the way, changes in the hurricane patterns. In an El Nino scenario, we tend to see less Atlantic hurricanes. So that's one thing you may see in the news as well. So this is where we are. We're going to ballpark this because we're still in the early stages. Officially from NOAA and the category, the division that looks at this, we're in El Nino watch status, just because we're not there yet, but everything's leaning that way. So they're trying to give people an early heads up. It's building steam. It's getting stronger. Every time we look at the numbers, it's inching up to be stronger and stronger in that critical early and midwinter period for us in California. It's likely to be strong, and it can be a big deal. Like I mentioned, 2 out of the 3 times it got to this status, it was a huge rain year for California and the West. So that's something that we want to get ahead of and not fall behind. But there's many other factors. Like I showed you, we have big bubbles of warm water in other portions of the Pacific and even the Atlantic, which could play into it. So there's a lot of different things happening, even if El Nino is established and starts to interfere and affect the patterns of the atmosphere. But there's one thing that's pretty consistent over time. You have your warm El Nino years and your cool La Nina years. Once we tend to see a big El Nino, it can change the global temperatures, ramping them up to a new degree, excuse me, and then keeping it there. For example, you could see for all these El Nino years, there was a ratcheting up, and even if there was a La Nina year, which could bring it down, it just didn't quite do enough. So you tend to see this trend during big El Nino years. In other words, regardless of what happens with temperatures in regional areas or with precipitation globally, we are expecting and are fairly confident that after all of this, we're going to see another notch up in the yearly average temperature and probably another notch up in the trend for temperatures going up across the planet.